Now that you've tried example 2, let's look at example 3 together because this is more complicated for sure, and that's mostly because of this term here. So we have to take the derivative of x times y. So we have a product rule in here. So x times y is a product, so we're going to have to use the product rule that we had in exam 1. So let's look at this first derivative here. So derivative of y squared is just 2y dy dx. We took the derivative of y with respect to x. Plus, we have the derivative of x squared, which is just 2x. And I could really write a dx, but I would never do that. I showed you it once, but we won't do it again because dx divided by dx is just 1. So derivative of x squared is 2x as usual. And then I have the product rule. I need to take the derivative of x times y. So first thing I'm going to do is take the derivative of my first factor. So I'm going to take the derivative of 1x, which is just 1. There's the derivative of x, my first, times my second. Derivative of the first times the second plus the derivative of the second factor, which is just a 1y, which will have a derivative of 1 dy dx. So we took the derivative of y. Derivative of the second times the original first, which is x. So notice this first term here, 1y, did not need a dy dx because I took the derivative of 1x, which was just 1, times the original y. Whereas the second piece, I did the derivative of the second, derivative of 1y was 1 dy dx times x. I needed that because I actually took the derivative of a y term there, whereas I didn't over here. I took the derivative of x to get 1 times my original second is y, equals the derivative of 7 is just 0. So be super careful. Make sure to take the derivative of the constant still to be 0. We don't want to keep that 7 hanging around when the derivative is 0. So now this one's harder because of the product rule, and it's also harder to solve for. So I'm going to solve for dy dx, and in order to do that, I'm going to try to get dy dx on one side by itself. So I'm going to figure out some numbers to cancel out, and I'll even do it in another color here. So I'm going to move my terms over. So I'm going to subtract 2x to try to keep the dy dx on the left. I'm going to move that over. And I'm also going to subtract that 1y because that doesn't have a dy dx either. So I'm going to move over anything that doesn't have a dy dx. That way, over here, this 2x goes away because I subtracted 2x, and 1y goes away because I subtracted 1y. So what I have left on the left side, and I'm going to write the dy dx's on the end. So I'm going to write it as 2y dy dx. And I always just keep the dy dx all the way to the right. So I'm going to write the next one, instead of 1 dy dx times x, I'm going to pull that 1 times x out front as just being x dy dx. I like to keep my dy dx's all the way to the right. So all I did was move that x out front times 1. Equals, what didn't have a dy dx is what I moved over. So I have negative 2x minus 1y, or just a y. And my next step is to still try to get dy dx by itself. So after you combine like terms, this is the hardest step to see on your own, I feel like. We need to get dy dx by itself, but it's attached to a 2y and an x. So what I need to do to get dy dx by itself is factor it out. So dy dx, I'm going to factor it out. It's times 2y in the first term, plus it's times an x in the second term. So I'm working to get dy dx by itself. I'm trying to solve for the derivative. So this equals a negative 2x minus y. Still on the other side. And now I'm finally ready to get dy dx by itself. I'm going to divide by this coefficient out here. I'm going to take out my 2y plus x. I'm going to divide by that. Since it's multiplied, the division will cancel out. And now these cancel, and I have my answer. There's the derivative. dy dx equals negative 2x minus y over 2y plus x. You might even want to rewrite it. If this was a test, of course, I would take a second and rewrite it out in another step, but that's good enough here in our notes.